Section 2.3, Truth Tables, Negations, Conjunctions, and Disjunctions, Video 2. The objective we will cover is construct truth tables with two simple statements that include negations, conjunctions, and disjunctions. Example 1. Given the statements P and Q, create a truth table for negation P, disjunction, negation Q. This can also be spoken as not P or not Q. So first off, we know we need to find the truth values of statement P, statement Q, not P, not Q, and finally the truth values for the statement not P or not Q. Now notice, even though we're asked to find a truth table for not P or not Q, P and Q are not even in the statement we're looking for, but I still need to find the truth values of each statement. So the truth values of P and Q are as follows. For statement P, we have true, true, false, false. For statement Q, we have true, false, true, false. For the truth values of the negation of P, they would be the opposite truth values for statement P. So that would give us false, false, true, true. The negation of Q have the following truth values: false, true, false, true. The opposite truth values of statement Q. Finally, our end goal is to find the truth values of the statement not P or not Q. So I'm focusing on these two columns with the arrows above them. And the final truth values would be false, true, true, true. So here are the truth values for the statement not P or not Q. Example 2. Given the statements P and Q, create a truth table for the negation of the statement not P and not Q or not Q. Here, we know we need to find the truth values of statements P, Q, not P, not Q, not P and not Q, the negation of the statement not P and not Q, and finally, our actual statement, negation of the statement not P and not Q or not Q. So first, the truth values of statement P. True, true, false, false. Truth values of statement Q. True, false, true, false. The truth values of negation P would be false, false, true, true. Truth values of negation Q is false, true, false, true. Now we need to find the truth values of the negation P and negation Q. So the arrows point to the two columns that I need to look at in order to find the negation P and negation Q, which would give me the truth values false, 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 true. To find the truth values of negation P and negation Q, I'm looking at the column that has the arrow above it and taking the opposite truth values. So I would have true, 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 false. Finally, I need to find my actual statement. So I need to find the disjunction of negation of not P and not Q or not Q. So the two columns with the red arrows above it are what I am focusing on. Because this is an OR statement, I have the truth values true, 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 true. So my final solution has the truth values of true, 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 true. Example 3. Construct a truth table for the statement given. So as I'm looking at the problem, I know I need to have P, Q, not P, not Q, not P or not Q, P and Q, not P or not Q, or P and Q, and finally the negation of the statement not P or not Q, or statement P and Q. So there's many columns that I need to find truth values in order to get to this end goal starred in red. So first, the truth values of P are true, true, false, false. Truth values of Q is true, false, true, false. Truth values of not P is false, false, true, true. Truth values of not Q are false, true, false, true. Now I need to find not P or not Q, which is truth values of false, true, true, true. I need to find the truth values of P and Q, which have the truth values true, false, false, false. Now I need to find the OR statement between these two columns, which would give me truth values of true, 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 true. I need to find the negation of not P or not Q or P and Q. The truth values would be false, 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 false. So the truth values of my statement given is false, 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 false. Definitions. A tautology is a complex statement where the final truth values are true for every possible case. We see this in example 2. Example 2, we have all truths, which is a tautology. A contradiction is a complex statement where the final truth values are false for every possible case. That we see in example 3. This is a contradiction. Lastly, we have a contingency is a complex statement where the final truth values are a mix of true and false. We saw that in example 1. We see this with example 1, a contingency. This concludes video 2.